In this video, we're going to explore properties of multiplication. Now, the first property we'll talk about is the commutative property. With the commutative property, we know that if we take A times B, that will give us the same product as B times A. For example, 7 times 3 is 21, 3 times 7 is 21, so 7 times 3 is equal to 3 times 7. Let's look at an array, as that can be very helpful. If you remember in a previous video where we talked about this, where we got the pennies, we could look at this as 3 rows of 8 pennies, which is 24 total pennies, or we could say that we have 8 columns of 3 pennies, which is 24 pennies. So whether we look at 3 groups of 8 or 8 groups of 3, we still would have 24 pennies. Now we start talking about area of rectangles. Area is using what we call square units. And with the square unit, what that means is that the square is 1 unit wide by 1 unit long. So if we said a square foot, that would mean that the square is 1 foot long and 1 foot wide. Now when we find the area of an object, what we're doing is we're taking the total number of square units it takes to cover the entire region with no gaps or overlaps. And when we talk about using rectangles, it's easy to see using an array. So say we want to find the area of a 3 by 5 rectangle. What we could do is we could recognize that that means we have 3 groups of 5, just like we had the pennies, or we've got 5 columns with 3 in it each, and we'd have an area of 15 square units. Now volume, instead of using square units, uses cubic units because it's 1 foot wide, or 1 unit wide, 1 unit long, and 1 unit high. That's why when you hear a cubic foot, it's 1 foot long, 1 foot wide, 1 foot high. And volume is the number of unit cubes it takes to fill a box or to create a box. So say we have the example of a box that's 4 cubes high, 2 cubes long, and 3 cubes wide. And we want to know how many cubic units that is. Well, here's my box. What I could recognize is that this represents 4 groups that are 2 by 3 units. And then I can say, well, 2 by 3 cubes means that there's 6 total cubes in that layer, and there's 4 layers. So 4 times 6 would give me 24 cubic units. Now when we get into these problems, especially with volume, we can recognize that we have the associative property of multiplication. And what this states is I can do a grouping of A times B and then multiply by C, or I can do A times the grouping of B times C. And if we look at the last problem, we can see why this would be possible. So I've got my 4 by 3 by 2, or cube, and I had my one breaking last time, which was the 4 groups of 2 by 3, which would mean I'm associating the 2 by 3 together first, and then multiplying by the 4. What I can also do is I can say I've got the front row of 4, and I've got a back row of 4 groups that have 3 in them, which would be the same as saying 4 by 2 by 3. Because if I look at 4 by 2 groups, that means I've got 8 groups of 3 blocks within each group. And it's 2 different ways of recognizing the notion of association. Now we can use our properties to our advantage. Just like in addition, knowing that we have the commutative and associative properties allows us to rearrange problems that are solely addition and solely multiplication to make them easier to solve. For example, with 5 times 13 times 2, I can multiply left to right like I would in any other problem. Or to simplify this problem, I could use the commutative property and flip the 2 and the 13 around. And that's perfectly legal because of the commutative property. 2 times 13 is the same as 13 times 2. Now, when I multiply left to right, I know that 5 times 2 is 10, and 10 times 13 is much easier to solve than 5 times 13, and that will give me 130.